Hi, we are back with one more video where we will be doing differentiation of this implicit function. What are implicit functions? So the functions in which we can't separate y in terms of x or vice versa, then they are treated as implicit function. Okay, so here the function what they have given to us, you can give it a try by taking anti-log or whatever method you want. You can't separate that as y in terms of some x. Okay, so we should follow implicit differentiation for such cases. Okay, so we will simply go with differentiating on both sides, and wherever we have to use product rule we will use it, chain rule we will use it. And just one thing to begin with, if it is, let's say, y square, then d by dx of y square will be 2y. 2y is just differentiation of y square, but differentiation of y will be dy by dx. So in short, differentiation of y square will be 2y dy by dx. That was just a demo what we are going to use over there. Let us begin with the question. So differentiation of left hand side is d by dx of ln x plus y, and on right hand side we have d by dx of x minus 2y. Right hand side is quite sorted. Let us start simultaneously with both. Differentiation of ln is 1 over whatever is there inside. Okay, so ln x differentiation is 1 over x. So here we have x plus y, so it will be 1 over x plus y. Then we have to use chain rule. Using chain rule, differentiation of x will be 1, differentiation of y is dy by dx. And on the other side I have directly differentiation of x will be 1 minus 2 dy by dx. So it will be just dy by dx multiplied by 2, obviously. Now here we have to separate out the terms because we need to get that form. And you can see that in final answer on right hand side we have this x plus y term. Okay, this is together, so it is suggested not to break off this 1 over x plus y. Keep it as it is in this form only. Okay, we'll see how to deal with that. So I'll expand it. On expansion I'll get 1 over x plus y plus 1 over x plus y dy by dx is equal to 1 minus 2 dy by dx. Okay, now this we can carry on the next slide. I'll rearrange the terms, so it will be dy by dx. On the left I have 1 over x plus y plus 2. Look at this coefficient, minus 2 comes on the right, it will become plus 2. And then on the right we have 1 minus 1 over x plus y. Okay, now as I was saying that here we have to keep in the form of x plus y. I will not change that thing at all. I will just do some more simplification, so it will be 1 over 2 times of x plus y over x plus y. Okay, and the right hand side it will be x plus y minus 1 over x plus y. Now we have this x plus y in both denominators that can be cancelled, and we are almost sorted now. So on the right we have x plus y minus 1, x plus y minus 1, and this term 1 plus twice of x plus y will go down over here, and you can see it will be 1 plus twice of x plus y. Now whether you write twice of x plus y plus 1 or this, it is same, and that is what they were asking over here, so hence proved. So this was quite a good question. It was a past paper question. You can see the process, you can see the steps. This is all what we have to show in the exam. So I hope that this is clear. If there is any other topic on which you want to have a video like this, please mention it in the comments. And if you understand this question well, then please consider subscribing our channel and like this video so that it will help the algorithm to boost it. Thank you.